For my project, I decided to look at magnetic resonance imaging and MRI machines. So first up, what is an MRI machine? What does it do? And why do we care? MRI machines are magnetic imaging machines that induce magnetic fields and they use radio waves to create images of our tissue and organs. In reality, they're just really large magnets that can induce really strong fields. And we use them all the time. We talk about the medical field and help diagnose patients, see where certain issues, specifically with cancer, are located, and so forth. To truly understand how MRI machines work and what they do in our body, we must first travel all the way back to 1937 to a Columbia University physicist named Isidore Rabi. He was able to measure the movement of a nucleus of an atom, and later dubbing this proton NMR. And he went to win the 1944 Nobel Prize in Physics for his achievement. His work allowed people to analyze and comprehend the chemical structures of whatever they were trying to test. Later on, around 1970s, a doctor named Raymond Damadian presented his idea to try and image and try to capture cancerous tissues by applying Rabi's work. His principle followed the ideas that cancerous tissues had more water content than those of the rest of the body. And if you can align the protons within your structure of water in a given instance, you can observe how it changes. And that higher concentration in those areas can be detected. Now, around this time, and not to his own devices, other physicists like Mansfield in England and a chemist named Paul Longerer were working on their own imaging modalities. They were a little bit behind him in terms of their steps, but they were also on the same type of work in the same field, trying to look at their own different types of way of using proton NMR in medical adaptation modalities. But in 1977, Damadian dubbed his work of a full body torso scan indomitable, and with a bit of a hiccup. So when he was first testing this out, he realized that he couldn't use an individual with higher body mass simply because his spectra and depth of field for his thing didn't quantify for it. And so he had to use a higher Tesla magnetic field in order to truly image, which he later went on to accomplish. However, Damadian's design was flawed and it cost way too much money and wasn't applicable in clinical settings. Thus, Lauterbur and Mansfield later refined his works and presented it to what we know as the basis for MRI machines now, and received the Nobel Prize in Medicine in 2003. So, on a molecular level, how does MRI machine work? Well, in our body we have water. Obviously, we're made of 70% water. In this water, there's hydrogen atoms associated with an oxygen atom, right? Two hydrogens for every one oxygen. Each one of these hydrogen atoms has their own inherent spin, as you can see in figure 1. They spin in this given direction, usually represented in chemistry and quantum physics as plus 1/2 or minus 1/2 spin, either one side or the other. However, when a strong magnetic field is induced, like that of an MRI, it lines up in the magnetic field, as you can see in the image 2, where the spin is going around the same axis as the magnetic field. However, when a radio wave and a radio frequency is applied to this, the pole and the spin actually changes somewhere around the 90 degrees, or all the way, as shown in figure 3, to 180 degrees. And then when the technician then removes that radio frequency, the hydrogen atom actually goes back to figure 2. It tries to go back to its initial orientation. But when it does this, it releases electromagnetic energy, and that's what the MRI machine can pick up. The time distance across is what the MRI machine can pick up. Here's another representation similar to what we had done in the capacitor lab in order to show that one side is positive and another side is negative in this MRI machine-like representation, where an individual and his hydrogen atoms, as seen by the red dot, will align to this electric field, flowing from the positive to the negative side. And then once they align, and then radio waves are turned off, and the electric energy is released, where we can quantify that release and how long it takes, how quick it takes, and we can image that release. Here's a possible question that could be asked in class, talking about the strength of magnetic field. Well, the answer would be A. And here is the Another question to talk about the strength, right? Because some MRI machines are very strong in the electromagnetic field, where Earth is really weak, and just to quantify how strong or weak it is. And then we're excited.